Hello friends, welcome to my YouTube channel. In this video we'll learn about the syntaxes used in Arduino programming. There are different types of functions in Arduino. To program Arduino boards, we will discuss all the basic functions in this video for pin controlling of Arduino. I hope you know all the things about the parts of Arduino. If you are not aware about this, then please watch the previous videos. There we discuss each and every part of Arduino in brief. You will get each of your question answer about Arduino, Arduino history, Arduino Uno board and Arduino IDE. If you want to learn Arduino without buying any hardware, then you can watch my last video. There I explain how can you use Arduino in Proteus. So in this video, we move one step forward and start learning coding of Arduino. Watch this video till end. For controlling the Arduino board and performing computations, we use different types of functions. We will discuss each and every function and its syntax in details. In this video, we learn about two functions. Here the first function is digital input and output, and the second function is analog input and output. In digital input and output, there are three syntaxes which we use in Arduino IDE. Here the first is pin mode, second is digital write, third is digital read. Pin mode, this is used to configure specific pin behavior, either it is input or output pin. You can see pin mode syntax on your screen. Here in place of pin, you can write pin name as on which pin you want to perform a task. As in Arduino Uno video, we learn digital pin 0 to 13. You can choose any number between 0 to 13 on this place and set that pin as per your requirement. And in place of mode, you can select either it is input or output pin. By default, all the pins are input pin. For input purpose, you need not to write this syntax. It is used when you jump from output mode to input mode. You need to use same type of syntax. If you change capital or small words in this syntax, then it is showing error in the program. Now you can see the example of pin mode syntax on your screen. In first, we make pin number 13 as output pin, and in second example we make pin number 12 as input pin. And here third option is also available, as you can see on your screen. This function we use when we use the pin as an input pin. This is used to activate internal pull-ups. When you choose pin mode as output pin, then you use digital write syntax to write the pin. It is also used in when you use pin mode as input, then there this syntax is used to enable or disable the internal pull-ups. In this syntax, first pin, you can select a pin number 0 to 13 digital pin and analog pin 0 to 5, and in place of value you select high or low. High means there is 5 volt when we operate the circuit on 5 volt and 3.3 volt when we operate the circuit on 3.3 volt, and low value is always 0. This function is performed when pin mode is output mode, but when pin mode is input mode, then this function is used to enable or disable internal pull-ups. As we write high on place of value, then it enables the internal pull-ups. As we write low in place of value, then it disables the internal pull-ups. There is 20K built-in resistor in 8MEGA328 microcontroller which we used in Arduino. Here you can see examples of digital write. In first example, we write digital pin 13 as high, and on second example we write digital pin 13 as low. On your screen you can see the example of LED blink. Here the first function is void setup, which run once when the microcontroller is on. In this function we define the pin mode as we select pin number 13 as an output pin. This is void loop. This function continues run till the microcontroller is in on state. Here we make digital pin 13 as high, which we select as an output pin. So on this pin it provides 5 volt. Then write a function of delay. Actually this function create 1 millisecond delay. If we write delay value 1, then it creates 1 millisecond delay. As you can see, we write a delay value of 1000. This means it creates 1000 millisecond delay, which is equal to 1 second. In this, we write distal pin 13 as low, and same delay function is used here. Basically, this function make LED glow for a second, and after that LED will off for a second, and when you see this is shows like LED is blinking. But why we need to use a delay in this program? Actually, microcontroller works on microseconds that a human eye can't detect. If we remove any delay, like I remove this delay, then it will glow for a microsecond, which we can't detect with the human eye. And same way, if I remove that delay, then LED will continue glow and off for a microsecond, which is not detectable for a human eye. That is the reason we use here a 1 second delay. Next is digital input. We use this function to take input from the pin, like when we use a switch or any sensor, then this function is used. With this function we can use internal or external pull-ups. What are the pull-ups? Like you want to detect a pin condition when it is 0, then you use a pull-up resistor with this to provide a continuous 5 volt or 3.3 volt as you required. The pin remains high till we don't press the switch. As you can see the pull-up and pull-down circuit on your screen. In pull-up resistor, when you press the switch, then the circuit will complete, and on microcontroller pin there is 0 volt on that pin. And in pull-down resistor, when you press the switch, then there is 5 volt on the microcontroller pin. You can use pull-up and pull-down resistor 10K, and also you can use internal pull-up resistors of the microcontroller as we discussed in previous slides. There you also need to add some delays when the switch press is detected. Actually these delays are used to remove the debouncing effect. Debouncing is when you press the switch. As you can see in the graph, there is switch off condition. Then when you press the switch, then there are some fluctuations, and after that when this goes to 0 volt, then your switch is pressed. To ignore these fluctuations, we use 10 millisecond delay, or in some cases it may be higher. But why this debouncing comes in microcontroller? Like our microcontrollers works on microseconds. Due to this, the speed of the detection is very high. So when there is a press detect, then we need to wait there for some time that it will perfectly sense that the switch is pressed or not. As you can see on your screen, digital read syntax. Here the pin number we use pin number 0 to 13, and analog pins use 0 to 5. Here we can't use D13 pin as an input pin in Arduino because a LED is connected on this pin. When we use this pin as an input pin, here also at Mega 328 internal resistor 20K value is also added. Due to this we get 1.7 or less voltage. Due to that low voltage, the input function is not work properly and sometimes fluctuate and sometimes not working. If we remove the LED and resistor, then we can use this pin as an input pin. We can also use analog pin as digital input and output pin. Just write the name like A0, A1, etc. Which pin we want to use, we can use. Next we learn about analog input and output functions. First function is analog read. Analog read function is used to ADC of at Mega 328 controller. ADC is analog to digital converter. For this analog read function, we can use pin on Arduino A0 to A5. Other pins are not applicable for this function, but digital functions we can perform on the analog pins. As I told you in Arduino Uno board video, that Arduino has 10-bit ADC, that maximum value is 2 raised to power 10, which is equal to 1024. As you apply voltage on a particular analog pin, it will give you a value. Here you can see the code of analog read. Here the first function is word setup as we discussed in previous slides. Next is serial begin. This is used to initialize the serial port with baud rate. Here we select the baud rate of 9600. Next is word loop. Next we define an integer VAL. In this function we put the digital value to integer VAL. Here you can use the analog pin A0, A1, A2, A3 and A5, and in this we shows the value on the serial monitor. If you did not connect anything on that particular pin which you want to use as analog pin, then this will show some fluctuating values. When you connect any source to that pin, then this will show you a stable value. Next is analog write. As I told you in Arduino Uno video, here you can see on your screen an Arduino Uno board. Here you can see before the D3 pin there is a wave sign which defines that this is a PWM pin, and D5 pin is also PWM, D6 pin, D9 pin, D10 pin, D11 pin. Those pins which shows the wave sign are the PWM pins. We can use the analog write function with these pins. As you can see on your screen, this is the syntax of analog write. Here first is pin. You can select the PWM pin which are on your board which you are using, and here you can select the value between 0 to 255. The PWM pins are able to generate with the PWM signal. As on Arduino Uno, digital pin 3, 5, 6, 9, 10, 11 are analog output pins which are also called PWM pins. Pin number 5 and 6 works on 980 Hz. Approximately this is 1 kHz, and other pins are worked on 490 Hz, that is half kHz. Basically what is PWM? You can see on your screen, this is the PWM signal. Here you can see T on, this is the on time, this is the off time. Here the duty cycle is 50%, means for a half time it is on and for a half time it is off. Here you can see the duty cycle is 10%. For example, the old duration from this point to this point is 100 milliseconds. 10% duty cycle defines that this pin will high for 10 milliseconds and off for 90 milliseconds. Here next you can see 30% of duty cycle. Here we use same time example 100 milliseconds from here to here. This is total 100 milliseconds. For 30 milliseconds this signal is on 5 volt, and for 70 milliseconds this signal is 0 volt. Now next is 70%. Here for 70 milliseconds it is on and for 30 milliseconds it is off. I hope you understand what is PWM signal. Due to this the voltage will reduce. Now we will discuss how can we calculate the output voltage. Here the formula is duty cycle over 100 into input voltage. Here the duty cycle is 10% and the voltage is 5 volt, and the output you get on that pin is 0.5 volt, which you can check with the help of the multimeter. Here on 50% duty cycle, here you can see the duty cycle which is 50%. It is the input voltage, and here is the output voltage which is 2.5 volt. Next is 30% duty cycle. Here 30% is duty cycle, 5 is voltage, and the output we got at that pin is 1.5 volt. Next is 70%. Here is duty cycle is 70%, 5 volt voltage, which power you use as an input power, and here is the output power. So now a question comes in your mind that how you can set duty cycle with this value. Here the value is between 0 to 255. For this you can use a different formula. As you can see on your display, here the duty cycle we want to set is 10%, and this is the maximum value. When you calculate with the help of this formula, you get the approximate value of 25. When you put 25 value in that function on that pin, then you will get 10% duty cycle. And now you also know how can you calculate the output voltage. Here next and the last syntax of analog input and output is Analog reference. This function is different for different types of board. In this video, we will discuss about the Arduino Uno board. This value is used to configure maximum voltage value of analog pin. Here first is default. This refers that 5 volt is maximum when you are using 5 volt in your board and 3.3 volt when you are using 3.3 volt in your board. For default, if you don't write this syntax, then Arduino will automatically pick the default values. Next is internal. It sets the reference to 1.1 volt if microcontroller is at Mega 328P and 2.56 volt if microcontroller is at Mega 32U4. Next is external. When we use analog reference external, as you can see on Arduino Uno board that these two pins A, REF and G and D are used for external reference. You can put a voltage on that two pins that you want to set the highest level. Like if you provide 4 volt on this pin, then the analog read pins will give 1024 maximum value at 4 volt. I hope all the concept which we discuss in this video is clear to you all. If this video is helpful for you, please press like and share this video with the needy persons. If you are new to my channel, please subscribe it and press the bell icon so that you get new videos notifications. Meet you in next video. Till stay happy, stay healthy and make learning part of your life. Thank you friends.